Okay, dear students, now comes another question. Question number 3. You are given two sets A and B, and number of A without B is given, and number of B without A is also given. So if you are given to be 80, and the intersection of number of elements you see is also 30. So you are asked to determine the number of the union of the two sets, number of A union B. So how do we determine this? So simple. Remember that. You see, the given information are this: number of A without B is 80, number of B without A is 80, and number of A intersection B is 30. So we know that number of A without B is number of A minus number of A intersection B. And also, here, number of A without B is given. It is 80. We don't know what number of A is, so let's have that as it is. But we knew what the number of A intersection B is. It is 30. So from this, one can simply know what number of A is going to be. It's a matter of taking minus 30 to the right, to the left. So number of A is going to be 80 plus 30, which actually is 110. So the number of elements in set A is 110. And proceeding to the next one, number of B without A is the same as number of B minus number of A intersection B. So as can be shown here again, look, number of B without A is 80, and number of B is unknown, and number of A intersection B is 30. So number of B can easily be obtained by just taking minus 30 to the left. So number of B is 80 plus 30, which actually is 110 too. So number of A and number of B are known, right? So number of A intersection B is also determined. It is 30. So it is so simple to determine what number of A union B is going to be. So recall this approach. The number of A union B is the sum of number of A and number of B minus number of the intersection elements, okay, within the two sets A and B. So everything is straightforward. Number of A is 110, number of B is 110 again, and number of A intersection B is 30. So 110 plus 110 makes 220. And when you deduct 30 from 220, 190 can come. So clearly, the answer for, you see, this is going to be 190. I hope you have understood. A very good question. Now what follows next is the next one, which is the fourth one. It says, find the real part of 1 plus I the power of 20. Look, you are given 1 plus I the power of 20, a complex number. You're not supposed to multiply this 1 plus I 20 times. Doing this is somehow tedious. You see awkwardness. So instead of approaching this, you see, in this way, what you need to do is you have to write the Euler form of this expression, 1 plus I the power of 20. And to do that, let you follow me how I'm going to do. 1 plus I the power of 20, students. Let's write the equivalent Euler form of 1 plus I. You see? And the equivalent form of Euler form of 1 plus I is determined by first finding R and theta. We have to determine, you see, R, the modulus, and the argument value. So our R is the square root of the sum of the real square and the imaginary square, okay? So clearly, the real part is 1 here. The imaginary part is again 1 here. So 1 square plus 1 square makes radical 2. So your R value is radical 2. Now according to Euler form, we need to determine the argument of this one. And the argument is obtained by taking tan inverse of the ratio of, you see, the real part with the imaginary part with the real part. And this makes 1 over 1, which actually is 1. So tan inverse of 1 makes pi over 4. So we knew what R and theta are here. So we can now write the equivalent Euler form for 1 plus I. It's going to be radical 2 cosine pi over 4 plus I sine pi over 4. Basically, this is a polar coordinate form. You see, directly obtained from this one. So its equivalent Euler form is going to be like this. Radical 2 into cosine pi over 4 plus I sine pi over 4 to the power of 20. But we can write this as like this, students. According to Euler form, R is a power of I theta. You see, R is a power of I theta. R is radical 2 is a power of I. Theta is pi over 4. So we can have radical 2 is a power of pi over 4I, according to that form. But now here we have written in polar form. It's going to be like this. And recall that whenever you come across with this 20 can come down in the multiple, what, pi over 4 here inside, because the property says so. So this radical, this 20 goes to the first one, radical 2. And here's what follows is 20 can come here to the power of, look, this basically goes to the power of 1 over 2. Right, this is to the power of 1 over 2, but 1 over 2 cancels 20, that multiples 20, so this is 10, as you see. And when you directly take 20 here, it will be 20 over 4 pi plus I times sine 20 pi over 4, because one of the properties says so, remember. So from this to the power of 10, cosine of, look, 20 divided by 4 is 5 pi plus I times sine 5 pi can come. And we knew that cosine 5 pi is nothing, but it is what, students? Look, you have to have xy axis, and you need to what, rotate for 5 pi times. So what is going to be for this is the next one. Look, cosine 5 pi is minus 1, guys, and sine 5 pi is 0. Sine of a multiple of pi is always 0, students. So this goes to 0, and then to the power of 10 minus 1 can come. So minus to the power of 10 can come. Look, student, instead of multiplying this 1 plus I 20 times, you see, thanks to the concept of Euler as well as polar coordinates together with the important here we have here, we can obtain that this is equivalent to minus to the power of 10 in a simple way. But you are asked to find the real part. The real part of this is the number itself, because we don't have imaginary part here. The imaginary part is 0, even though it's not written, okay? So the real part is the number as it is, but we knew that to the power of 10 is 1024. So we do have minus in front, negative 1024 can come. So from this you can understand that, you see, the real part for this is negative 1024. In fact, it's not the real part alone, even the number after simplification of 1 plus I to the power of 20 is negative 1024. I hope you have understood the idea. After having this, what comes next is, you see, the coming fifth question of the filling the blank part. A polynomial p of degree 6 has zeros of minus 3 and 2 with multiplicities 4 and 2 respectively. You are given that p of minus 1 is negative 288, and you are asked to determine what p of minus 2 is. So in order to answer this, you need to recall about how multiplicity and zeros of a polynomials are defined. You need to know that, okay? So this question strengthens these concepts. So here it is. A polynomial of degree 6 with zeros of minus 3 and 2, you see, with multiplicities 4 and 2 respectively, and p of minus 1, negative 288 is obtained as follows. Look, this is a polynomial in general. P of x, the polynomial having a multiplicity 4, as you see, and 2, because it says so here, multiplicity is 4 and 2. The zeros are minus 3 and 2, so x plus 3 has to be taken because it is minus 3 that makes this 0. Look, it is. And here x minus 2 has to be taken because if you put 2 here, the whole turns to 0. So look, everything is written, but we don't know the coefficient here. You don't have a certain real number in front, but that is supposed to be determined by using this one. P of minus 1 is negative 288. So look, to find the value of k, you need to use this one. P of minus 1 is negative 288. So what we need to do is this. Just substitute minus 1 in place of what? X here, and equate that with negative 288. So minus 1 plus 3 makes 2, and to the power of 4 makes 16. And minus 1 minus 2 makes minus 3 squared. Turns to be 9. So k times 16 times 9 equal to negative 288 is going to come. And it is from these that we can determine the value of k. So clearly, this is going to be what? Minus 2, because 16 times 9 makes 144. You see, this makes 144. So as you are dividing negative 288 by 144, k turns to be minus 2. Now k is obtained. Our intention is to find what p of minus 2 is. But before we determine what p of minus 2 is, let's determine the polynomial. So already minus 2 is obtained, so we can directly substitute this minus 2 in place of k. So this is going to be what? P of x is equal to negative 2 x plus 3 is the power of 4 into x minus 2 squared. Nothing is done. I simply have substituted minus 2 in place of k here. You see, everything comes as it is. So this is the general polynomial, you see, that we can have. Had we been asked to determine the polynomial, this could have been the answer. But the question is, what will happen for p of minus 2? So substitute minus 2 in place of x. So when you put minus 2 in place of x, this turns to be like this. P of minus 2 is minus 2 plus 3 makes what, student? 1. 1 the power of 4 is 1. 1 times minus 2 is minus 2. And here minus 2 is minus 4. Square is 16. So minus 2 times 16 makes minus 32. So what we need to put in our C blank space here is minus 32. I hope you have understood, you see, the idea of the question and the solution too.